Let's take this previous JEE Advanced question. Let R denote the set of all real number f R to R be a function such that fx is greater than 0 for all x belongs to R and f of x plus y is equal to fx into fy for all xy belongs to R. So this is a standard functional equation, and we can directly say the nature of the function that it will satisfy. We know that fx equal to some k power x, where k belongs to R plus, satisfies this functional equation. Exponential function like k power x. Now k is of course any positive real number. Now if we come to the next one, that is, let the real number a1, a2 up to a50 be in arithmetic progression and f of a31. So what is f of a31? That is, f of 31 term of an AP will be a1 plus 30d. We know from the AP concept that 31st term of a series is first term plus 30 into d. D is the common difference. So that will be equal to k to the power a1 plus 30d. And 64 times f of a25. So f of a25, 25th term will be a1 plus 24d. So that will be k to the power a1 plus 24d. So if you use this condition, so that means k to the power a1 plus 30d is equal to 64 times k to the power a1 plus 24d. So if you divide this factor by this factor, if I divide left hand side by this right hand side factor, then I will end up with k to the power difference in the power, that is k to the power 6d is equal to 64, that is 2 to the power 6. That implies k to the power d must be equal to 2. K to the power d of course must be positive only because k is positive. So k to the power d equal to 2. This is what we have got. Next, another condition is given, that is summation fi, summation fai, that is f of a1 plus f of a2 and so on up to f of a50. This value is given to us. So this one is going to be f of a1. So if you substitute in the function, it will be k power a1 plus f of a2, that is k power a1 plus d. We know d is the common difference of the AP. And this continues up to f a50, that is k to the power a1 plus 49d. So you can see that this is a GP series. This is a GP series because this is first term plus k to the power a1 into k to the power d plus k to the power a1 into k to the power 2d, that is k to the power d square, and so on up to k to the power a1 into k to the power d power 49. So this is a GP series. And the sum of a GP series is the first term k to the power a1 into the common ratio, that is k to the power d, to the power number of terms. Number of terms is counting 50 terms. 50 minus 1 divided by k to the power d minus 1. So k to the power d value we already have seen, it is 2. So substituting 2 here, we will get k to the power a1 into 2 to the power 50 minus 1 by 2 minus 1. This is the sum of the GP, and this is given as 3 into 2 to the power 25 plus 1. So you can see that this is denominator is 1 and 2 to the power 25 plus 1 will be cancelling, dividing 2 to the power 50 minus 1. So that will give you k to the power a1 into 2 to the power 25 minus 1 is equal to 3. We will get another relation. K to the power a1 into 2 power 25 minus 1 equal to 3. Finally, if we come to this particular summation, what it is going to be? Let us see. So this is going to be f of a1, though this is starting from 6, f of a6 plus f of a7 and so on up to f of a30. We need to find out this particular sum. So if you substitute in the function, it will be k to the power a6, that is a1 into k to the power 5d plus f a7, that is k to the power a1 into k to the power 6d and so on up to f of A30, that is k to the power A1 into k to the power 29t. So this is again a GP series. I can consider the first term to be k to the power A1 into k to the power 5d. This is the first term into common ratio k to the power d power number of terms. How many terms are there? From 6 to 30. Total 25 terms are there. So power 25 minus 1 divided by k to the power d minus 1. This is the sum of the GP. And we already know k to the power d value, we already know it is 2. So substituting k to the power d value, it will be k to the power a1 into 2 power 25 minus 1 into this factor, that is 2 to the power 5 divided by 2 minus 1. Now we can substitute this factor here. This factor here, this is 3. So it will be 3 into 2 to the power 5 by 1. So that is 3 into 32. So answer is going to be 96.